Hey, hello and welcome to today's GFG problem of the day. Hope you're doing well. So let's say today's problem, overlapping intervals. Okay, what the problem is saying is we'll be given an array of intervals. Okay, and where array of I is start and end. Okay, the task is to merge all of the overlapping intervals. Okay, so let's see an example. So here is the example array, right? So here what the problem is saying is we'll be given an array of intervals. So this each element is an interval. Okay, and within each interval there is a start of an interval and end of an interval, start of an interval and end of an interval. Okay. And what the problem is saying is we want to merge all the overlapping intervals. Okay. All the overlapping intervals. Now, how to define what is an overlapping interval? So the overlapping interval, let's see an example, right? So this is an interval, this particular case, right? 1, 3. And then this particular interval starts at unit 2 and ends at unit 4, right? Unit 4, right? So how can we say, when can we say that that there are two overlapping intervals? Okay. So when the start of the current interval is less than the end of the previous interval, right? So this interval is yet to end when this interval has started, right? So this particular interval has started before this particular interval has ended, right? Before this particular interval has ended. And that is why these we can say these are two overlapping intervals. Okay. Okay. Now, now, now let's try on how can we solve this problem? Okay, using the overlapping property we just discussed. Okay, so here for example, so definitely these two intervals are overlapping. So in that case, what we are going to do? We are going to take the minimum. We are going to take the minimum out of these two. Okay, so yeah, we are going to take the minimum out of these two out of the start intervals. Okay, so what is the minimum one? So this is one, right? And we are going to take the maximum out of the end of the two intervals. So here the maximum is 1 4, right? 1 4. Okay. Now let's see the next one, next interval. So we have merged these two intervals and this is the merged interval. Now let's check, let's compare this interval with this particular interval. So is there any overlap? No, definitely there's not an overlap because 6 is 6 starts after 4 ends. So for example, right? So here is a case 1 and 4, right? This is the previous interval and the next interval starts at 6 and ends at 8. So you can see there's no overlap. There's no overlap here, right? Right? So we will add 6 8 as is. We'll add 6 8 as is. Next one, if we compare this interval with the previous interval, so 9, right? The start time is after the end time of the previous interval. So it is going to be what? 9 and 10, right? 9 and 10. So this is a resultant. This is a final set of intervals basically. Okay. Okay. So I hope you've got now the problem. Okay. Now how can we solve this problem? Okay. So let's quickly see another example. Let's quickly see another example. Um, let's take this particular example. Okay. Let's take this particular 6 comma 8, 1 comma 9, okay, 2 comma 4 and 4 comma 7. Let's quickly write down these intervals as well. So here the first interval starts at 6 8, right? The second interval starts at 1, right, and ends at 9, right? 1 and 9. The third interval starts at 2. Sorry, let's write, maybe, yeah, we can write here 2 and 4, right? 2 and 4, right? And the last interval starts at 4 and ends at 7, right? 4 and ends at 7. So if you see, we can say that this particular interval 1 to 9 is a superset of all the intervals. Is a interval which contains all the intervals, right? Which contains all the intervals. So we can say that this is the resultant interval, we'll say. This is the resultant interval 1 9, which contains all these intervals. Okay, which contains all these intervals, and which is the whose start time is the minimum and end time is the maximum. That's what we're going to take. Okay, now we'll see how can we achieve this 1 9 out of all these intervals, right? How can we achieve this 1 comma 9, right? How can we say that, okay, this is the merged interval, this is the final interval? Let's quickly see. Okay, so whenever there's an interval problem, right? So generally ask for overlapping only. Okay. And to solve the problem, right? To solve this problem, we have to we have to sort the array, the intervals array, okay, according to the start times. Okay, according to the start times, definitely. And second thing is, second property is, or second step is, right? How do we find overlapping? For example, if the, for example, this particular, let's say, right, this particular thing, right, this is an interval and the next interval is this. So if the start time of the current interval is less than the end time of the previous interval, right, is less than the, then we can say overlapping. So this is the property of overlapping. This is how we can determine whether the two intervals overlap or not. Okay. Okay. Now let's see. Now first step we follow. We'll sort the array according to the start times. Okay. According to start time. So what will the array look like? It will look like something like this. 1 9, then 2 4 is 2 is the minimum start time. Then 4, right? After 2 comes 4 comma 7, right? We are sorting according to the start times. And then comes 6 comma 8, right? 6 comma 8. So step 1 is done, right? Step 1 is done. Now step 2, what we are going to do? We are going to check for the, we are going to check for um, the overlapping property. Okay. So first of all, uh, so what we're going to do, we are going to have this resultant, okay, result array, which is currently empty. Okay. Now, so what we're going to do, we are going to run a for loop, okay, over this array. Now, whenever result is empty, so we straight away, what we are going to do, we are going to insert the first element as is. Okay, we have inserted the first element as is. Okay. Now comes the second element. Okay, now comes the second element. So what we're going to do here is, so we're going to check the overlapping property. So how? So for example, there's this 1 9, right? And then there is this 2 4, right? 2 4. So what is our overlapping property? The start of the current interval is less than end of the previous interval. So yes, so it is following the property. That means it is an overlapping. These two intervals are overlap. So what do we do generally in this case? So this 1 9 is already in the result array, and we can say that the, since we have sorted this according to the start times, right? Start times. So this particular start time, it is going to minimum. It is going to be minimum. Anyways, we don't have to touch that. Only thing is, what we want to touch is, we want to compare whichever is a maximum, right? We want to compare whichever is a maximum. We're going to take that. So in this case, 9 is maximum. So we are going to keep it as is. Okay. If such had been the case, for example, if it was 2 and if it was something 11, right? Then in that case, we would have compared the end times of both the intervals and we would have taken maximum, which would have been 11. And here we would have been 1 comma 11. Okay. But that is not the case. So now it is going to be 9 itself. Okay, we'll go ahead to the next interval. We're going to check this. So next interval starts with 4 7, right? Sorry, you don't have to take like this, 4 and 7, right? 4 and 7. Okay, again we're going to check the overlapping property. The start time of the current interval is less than end time of the previous interval, we can say. How are we going to check previous interval? We're going to check in the result array, whatever was the last or latest or the previous interval. Okay, now 4 is less than 9. Definitely there's an overlapping, and we won't change anything like the start time in the result, because since again we have sorted according to start times, then we can safely say that this is a minimum. No need to compare 1 and 4, because 1 is going to be less only. Okay, what we are going to compare is the 7 and 9. We are going to compare the end times, and whichever is maximum, we're going to take that, consider that. So this is 9. Okay, so we'll keep it as is. Okay, then comes this last one. Okay, then comes this last one, which is 6 and 8, right? 6 and 8. Okay, 6 and 8, right? So again, we're going to check for the overlapping property. Yes, 6 is less than 9, right? 6 is, that means we can say overlapping, it's overlapping. So we're going to compare 9 and 8. Again, 9 is maximum, so we will keep it as is. And this way, we are done processing all the intervals, and this is a resultant, and this is a resultant. Okay, this is a resultant array. Okay, now for example, let's see another case as well wherein there are no overlapping, right? Let's dry run this particular thing. Okay, let's dry run this particular array. Okay, it will take some time, but I think you will understand all the cases, right? Let me copy this. Okay, so for example, let me take this again. Let me move it. Yeah. Okay. Anyways, so this is, for example, this, let's consider this is 9, 10 only. Okay, this is 9, 10. Okay, now what are we going to do? We are, first of all, we are going to sort according to start times. So if you see this is already sorted, so no need to, let me write here 9, comma 10. Okay, it will be clear. So no need to, I mean, this is already sorted according to start times. Okay, step one is done. Step two, we are going to check for overlapping. So first of all, we have our result, which is empty. So we're going to push our 1, 3. So 1, 3 is here, right? 1, 3 is here. Now, next step is definitely we are going to come to this particular interval and we're going to check for the overlapping. So the start time of the current interval is less than n time of the previous interval. That means we can say it is overlapping. Okay, we can say overlapping, and and we no need to check the start times. Okay, because we have already sorted those start times, and whatever is the result, right? Whatever is the result, okay, yeah, what is the start time in the result? It is definitely minimum. Okay, what we're going to compare here is the n times, and whichever is maximum, we're going to take that. So what we're going to do, since we need to merge this, right? So we are going to just update this end of the previous interval, the merged. Now this is a merged interval, we can say 1, comma 4. Okay, now we have 1, comma 4 here. We are going to compare with 6, comma 8. Are they merging? 1, let's see, 1, 4 and 6, 8. 6, 8. No, they are not merging. They are not overlapping, right? They are not overlapping. So we are going to add this current interval as is because they are not overlapping. Okay. Then comes 9, comma 10. Again, this starts with what? This starts with after the previous interval, after this particular interval, right? 9, 10. And we're going to compare, is there overlapping? No, it's not overlapping. So we are going to push this particular interval as is 9, comma 10. And this is our resultant array. Okay, this is our resultant interval. Okay. Now I hope you have got the intuition. Now let's go and code. Okay, you'll understand better. Before going to the code, please subscribe to the channel, like the video. Okay, let's quickly code. First I'll show the Java code followed by C++. So let's do our first step, arrays.sort add, then comes our we are going to iterate now the intervals, right? We're going to iterate the intervals, add. Now then post that, what are you going to do? Let's have our resultant, right? Resultant, they want in like this list of array, basically. Okay, let's say this is result and new array list, we can say. Okay, so what are we going to do? First of all, if the result is empty, then we are going to add our interval as is, result dot add, right? Interval. Okay, so right, because the result is already empty, there's nothing to compare, right? Second, when we are going to add again, the second case is if there's no overlapping between the current interval and the previous interval. So how are we going to check that? So we are going to take the last or the previous interval, result dot size -1, and we are going to get, this is going to get our previous interval, which is array, right? Which is basically what? So we're going to we're going to compare the end time of the previous interval. This is how we are comparing. If it is, if it is, if it is less than the start time, right, of the current interval, that means there's no overlapping, right? That's what we said, right? For example, this is a case again, 1, 4, right? And 6, 8, 6, 8. Now, what we are saying according to the statement. So this is the previous interval's end we are comparing, right? If it is less than the current interval, okay, if it is less than the current interval start time, right? So this is the current interval start time and this is a previous interval's end time. So we are comparing. If it is less than the current interval start time, that means there's no overlap, right? It is less. There's no overlap. So we're going to add the current interval as is into the resultant array. If we find it, no, if this case is violated, if this condition is violated, that means there's an overlap. In that case, what are we going to do? In that case, we're going to do the maximum result dot, we're going to take the maximum of the two of the n times of the two intervals of the current and previous interval, right? And we are going to assign it to, right? We are going to assign it to mat.max. We are going to do mat.max, control V, right? And interval of 1, right? We're going to compare the end of the two intervals and we're going to assign the maximum to the merged interval, which is already part of result. We have already seen this, right? So this is it. This is a code. Finally, we are going to return our result. Okay, let's compile. So what is the time complexity here? So we are sorting the array. So the time complexity, it is going to be of n log n. Let's quickly see what is the problem here. Arr interval. Oh, okay. My bad. This is not just, this is an array, we can say, right? It's a multi-dimensional array interval. Yeah. Okay, we found something comparable. Okay, array dot sort. Oh, my bad again. We have to sort, right? We have to write our comparator, right? Comparator. So what we are going to do? We're going to sort according to our start times. So this is how we do, right? B of 0, A of 0, B of 0. We are sorting according to start times. Okay. Maybe this should compile now. Okay, yes, let's submit it. So the time complexity here is O of n log n, and then we are iterating through the array which is O of n. But since this is maximum, so we are going to consider that O of n log n. Okay, so yes, it is successfully passed. Thanks for watching. Don't forget to subscribe to the channel, like the video. Let's quickly see the C++ code. So here's the C++ code. We have a resultant, a vector of vector. Then we are sorting, right, according to the start times, and then we are iterating to the interval. If the result is empty, we are going to add, or if there's no overlapping, then we are going to add the current interval. If there's an overlapping, we're going to take the maximum out of the the maximum of the end times of the previous interval and the current interval, and we are going to assign it to the merged interval, right? We are going to assign it to the merged interval, basically, which is previous one. We're just updating the end time, the maximum end time. Okay, so this is a solution. I hope you got the solution. Please subscribe to the channel, like the video. Have a happy, healthy, wealthy, and a great day. Thank you so much.